Hi everyone and welcome to the video. Today I'll be talking about signed numbers. So unsigned numbers only represent positive values. Signed numbers, on the other hand, represent both negative and positive numbers. So if you're given a set of binary numbers of ones and zeros, how do you know if that binary set represents a value of negative or positive? Well, to distinguish if the binary set represents a negative value, the most significant bit has to have a value of 1. So in these three number sets, binary sets, you notice that the most significant bit is a 1, meaning that they all represent a negative decimal value. So how do you represent a negative decimal number in binary? First, you have to negate the binary set, then you have to do 2's complement, meaning you add an increment of 1. So in this example, as states express -3 in binary with 3 bits, we know that 2 plus 1 gives us a value of 3. And in order for us to add those two numbers, you have to give those bits a value of 1. So we have 0, 1, 1. First you negate, meaning you change the zeros to ones and ones to zeros. So now we have 1, 0, 0. Then you do 2's complement, so you add an increment of 1 or 1 unit. So now we have 1, 0, 1, and that's -3. So what happens if we want to go back? Well, again, from negative to positive, you use negation and 2's complement. So we change the 1, 0, 1 to 0, 1, 0, and then do 2's complement, add a unit of 1, and we go back to 0, 1, 1, which is a value of 3. In the next example, we have what decimal value is 1101? Well, first you negate the numbers and you have 0, 0, 1, 0, and then you do 2's complement and now you have 0, 0, 1, 1, which equals 3, meaning that 1101 gives us -3. So we have 101 from the first example and we have 1101 from the second example. They both give us -3, and the answer is yes. The extra ones you add to the left don't play any role. So when it comes to the number 7, we have to give the first 3 bits all the way to the right the number 1, because 4 plus 2 plus 1 gives us 7. So any zeros you add to the left don't play any role. Well, when it comes to signed numbers, when you're working with when you're trying to represent negative values in binary, the ones all the way to the left, the most significant bits, don't play any role when it comes to showing a negative value. So the formula here is that when it comes to unsigned numbers, you could go from 0 to 2 to the n minus 1. The -1 is not to the power. N represents a number of bits, but signed numbers, on the other hand, consists of -2 to the power of n minus 1 is the lower boundary that you could go up to, 2 to the power of n minus 1, and then -1 gives us the high boundary that we could go up to. So for example, if we have 3 bits, we have the number 3 all the way to -4. So if we put the 3 bits, if we replace n with 3 representing 3 bits, we have 2 to the power of 3 minus 1 is the lower boundary, 2 to the power of 3 minus 1, and then -1 gives us 2 to the power of 2, and make sure to keep the negative outside. Then 2 to the power of 2 minus 1, and that gives us our lower number is -4 and our highest number is 3. So the last thing I want to cover is values, variable values that we use in C programming. So why is this important? Well, when it comes to embedded systems, memory is very important. You want to make sure that your code can take the least amount of memory to perform the best it can, to be as efficient as it can. So you have to make sure that, hey, if I want to represent a whole number of, for example, values of 50 to 100, I could use a unsigned character, unsigned char, which consists of 1 byte. So an integer consists of 2 or 4 bytes. Unsigned integer consists of 2 or 4 bytes because they vary in in particular with the compilers that you're working with, meaning that the compilers are what upload your code to a hardware or to the system. So depending on what your interests are, whether I'm trying to represent the number -1000 to +2000, I could use an integer. I could use a short. I could use long. I could use that's pretty much it. But what happens if I use an integer for a value, a variable, and I only have to go to 0 to 1000? Well, you can use it, but when it comes to memory, when it comes to, like I mentioned, embedded systems, you want to make sure that you use up the least amount of memory, which allows your system to be very efficient. And in the lower 3 examples, float, double, and long double, those are examples when you want to represent when you want to show decimals. For example, when it comes to temperature sensors, when it comes to height or time, you want to represent you want to make sure that the data you're reading is displayed, and you want to be very precise, meaning that you want to make sure that you go up to 6 decimals or 15 or 17, or for example, the max you could go to is 19 with a long double. So if you made it to the end of this video, I appreciate it. Hit the thumbs up and subscribe because I release videos weekly. Thank you.